I believe it has started recording. Cool. Okay, so back to more non-C++ topics. Let's continue with Java. Let's do slightly fancier things in Java, and then we'll wrap that up and do a little bit of Python and call it a day. So I think my next bigger example in Java, let's build up a counter class to see the differences. Remember the counter class from before? A nice simple example of how classes work. So we'll just build up a counter class so that we can make an object like C, for example. And in the constructor, we can set the count to 0, and we can call like c.inc. And that will increment the count to 1. Do that a couple times, make it 2, whatever. Maybe we'll also have a reset method. We'll make a c.reset method. And that will get the count and get rid of it. Or maybe we'll also overload the reset method so that it can also do like something like this, reset it straight to 42, something like that. That could work. So yeah, a couple kinds of reset, as well as inc, a constructor, get count, all those things that you need to have. So let's see how they work in Java. So if I want this to be called counter, the class to be called counter, usually it's capitalized when you make a class name in Java. That's the common way to do it. If I need to make a class called counter, and that's my public class that everybody gets to use, then I better write this in a file named counter with a capital C.java. So that's where I need to be writing this. And with that, let's make our public class that we know we need. Public class counter, and eventually we're going to have a main function. It's going to be different. It's a static method, so we treat it like a function. We think of it as a function. Public static void main string args, and the bracket goes next to the name of the type. It's very cool. And so I'm going to be defining a counter class. So I'm going to be using it in the main function, like counter c equals new counter. But this main function, you don't think of it as being like a method of the counter class. It's a bit different because it's static. So please look up the term static if you're interested, because main is static. It's not really a method that's part of an object. It's a part of the class. So we think of it as just one thing, kind of like a function. It's not really a method that's part of any individual counter object. So that's why we can do this. And then, all right, if I'm going to make a counter, if I want to make an object, I always have to say new. Everything lives on the heap in Java except for those simple variables like int, those primitive types. So counter c equals new counter. I want to be able to use like c.getCount, right? So let's print out our current count. Better start at 0. System.out.print ln, that prints the thing with a new line at the end. So that should print, we should see 0 when we print this one. And then we can call inc, right? We want to increment the counter. We want to implement this method. And then it should print not 0, but 3. We should be able to call c.reset, which will set it back to 0. And maybe if I call inc twice more, it should make the count 2. So we should see 2 if we print it now. So yeah, that's all working. All right, we want to also make sure that we can reset to arbitrary numbers, like, I don't know, 42. So this should make it 45 now, if I inc it 3 times after that. And I think that's a good enough start. So that's my first counter. This is how I want to use it. So let's go and make all of these things that we need. All right, so constructor, get count, inc, reset, all this kind of stuff. Remember, there's no concept of like pointers. Everything's like a reference, even when you get it back from new. So you can use dot immediately. And we have to put public and private next to everything. We can't just say public colon, private colon, and everything below becomes public / private. No, we got to do it one by one, sadly. That's just how Java likes it to be done. Okay? So I need a private int count. That's going to be my member variable. Okay. That's our one field. We'll need one field called count. Count is private. And we have to put that right next to the name of the variable. And then also, one thing that we don't do in Java is declare things. There's no such thing as declarations in Java. There is no such thing as function/method declarations. And then you also can't say, public colon or private colon. You got to put the public private next to everything. So private int count. All right, let's make the constructor. Again, we don't declare it. We can put anything in any order. Java will always find it. That's another reason there's no need for a declaration. But let's make a constructor. Structure. Well, it's public. All constructors should be usable by the user, so it's public. And there's no return type, but the name is the class, just as usual. Public counter. And there's no like initializer lists or anything, but what do we need to do with our counter's constructor? We better set the count to 0. So count equals 0. That will be our constructor. Does that make sense? That's not too horrible. What else do I need? I need get counts, inks, resets. Let's do all those. So these are all public methods, right? Public int get count. Return our count. You cannot have a const method in Java that doesn't exist. I guess there's a way, but it's not. It's a little complicated. We can't mark a method as const very easily, is what I should say, in Java. You can do some fancy annotation style things, but I don't want to get into that. You can look it up. Public void inc. Count plus plus. That's all the same. One interesting thing is, in C++, we could have made the reset method like this, because I can use the reset method without parameters or with a parameter. If I don't use anything, it like defaults to 0. You can have that kind of default thing in C++. You remember that? So I could do something like, this is not correct, by the way, what I'm about to write. This is something that you would be able to do in C++. Public void reset, like int new count equals 0 or something, and then set the count to new count. And if you don't give anything, it'll just default it to be 0. Otherwise, if you give something, it'll actually replace the new count with something. This does not work in Java, sadly. So Java doesn't have default parameters. So you have to make 2 separate reset methods. So you have to make 2 separate reset methods. One with a parameter, one without. That's the one with a parameter, and then the one that would be like the default one is just, you gotta hard code it. Set it to 0. Okay. So that's all that. Any questions about anything I've written? Because I think that should be good enough. And then we've implemented it all, public class counter, and here's our main function that uses counter, and hopefully we see the same numbers that we see when we in these comments. So Java C to compile. That's a good sign. It made counter.class without yelling at me. And then Java counter to run it. Yay, 03245. Awesome. You're good with that? What else do I want to do? One sad thing about Java that I definitely prefer about C++ is that you cannot overload operators in Java. You can't make like operator plus so that you can do something cool like C plus C2 if you make another counter object. Sadly, in Java, this must be spelled out. You have to make methods with words. So it's got to be like C.add C2 or something. That is very unfortunate, but that's what we're forced to do in Java. Cannot overload operators. So let's have an example of when we might want that. Let's make a new counter. Counter C2 equals new counter. Call the constructor C2.inc. So it'll make it, what, 3? So now it's 3. And now the other one was 45. And so if I add them together, for some definition of add, let's pretend that adding 2 counters means adds their individual counts. Back a brand new counter. So counter C3 equals C.add C2. I'd like this to give me back 48 if I print C3. All right, so let's make this add method. And that should finish us off. So if we say C.add C2, we're going to jump up to here to our public counter add method that takes some other counter. And so it's always, we got ourselves, we have our own count, and then we want to add that to the other's count. And so the new count in some count, I don't know, equals our current count plus other.count. Okay, that's how it works. And we need to give back a brand new counter. Counter results equals new counter, and we need to return that. But what do we put in it? We'll just call the reset method on it. Why not? We'll put in that summed count. That's how we'll add 2 counters and give back a third counter. Okay, so kind of the same as we did before. We just don't get cool operators anymore. Alas. Did I make a mistake? Oh yeah, sorry, I forgot to call the constructor properly. In C++, you didn't have to do that. That's why I'm confusing myself. Compile, run. We're going to jump up here, add the 45 to the 3, make a counter with 48 inside, return it, and when we call get count on it, we do in fact get our 48. Awesome. That is my example counter class. Any questions about that one? That's how you do it in Java. All right, let's talk about, let's list some differences between Java and C++. I stole this from the other computer science professor's slides. Thank you, Bill. So first of all, as we've said, Java is compiled to an intermediate language. It's not compiled to machine code. There is like something in between. It's called byte code, and you've got to give that to the virtual machine, Java virtual machine, to actually go and run it. So it's slightly slower than C++ because of that. You can make constants. You can't make const methods, but you can make constants, and those are marked as final. Instead of const, they say final, like this is the final value you can give this once and for all. And usually you make it a static variable as well, because you just want it to be part of the class, just want it to exist once. That's what static means. Instead of char, they say byte. Instead of bool, they spell it out and do boolean. There's no pointers, only this weird thing that they call references, which we've seen, like you call new and you get back a counter. You don't put an ampersand, you don't put a star, it's a reference. It does it for you, which is nice. Can't overload operators, which is unfortunate. Instead of bool operator less than, you got to be like bool public bool less than. You got to spell it out. If you're trying to like include a library, it's not number sign include. I'll show you that later. Then you put a semicolon at the end, which is weird because you don't put a semicolon at the end in C++. You'd think that you would, but you don't. Maybe you've tried that before. There's an interesting thing going on in terms of inheritance. Do you remember how I told you like every IF stream is an I stream? And the fact that you can do the less than operator on an IF stream is coming from the fact that it's an I stream. It's inherited that property somehow. And also, C in is an I stream? Sorry, if I'm talking about I streams, I gotta use the other arrows, don't I? It's an input stream, it better be going that way. So the same kind of thing is going on with the object class in Java. You'll have to read about inheritance in your book if you'd like to. But like when I make a counter class, it is just implicitly inheriting from a class called object in Java, which gives it some nice properties. Like it has a toString method already implemented for it. It has like an equals method implemented for it. You get a lot of interesting things, but implicitly that's all there. Everybody inherits somehow from object in Java if you make a class. Okay, that's not something you need to worry about, but at least I'll tell you it once so that you've heard it. It's really nice to use Visual Studio Code if you've tried that with Java. To use a fancier, to use even what is it called these days? I forget the most popular one, but it used to be Eclipse was the most popular development environment for Java, and it just underlined all the bad things, and it was just so helpful. So they're really good with the Java compiler about telling you hints about making your code better. There's also a nice way to just automatically extract documentation from your files. We showed this, not that one. We showed this page before last time, this documentation page for the print function and all that. This is this is the entire Java standard library, by the way. There's a lot of stuff that you can click on, but this entire page, it was automatically generated from the code. It was extracted. And so that's really helpful when you're trying to come up with documentation. That was just all automatic, very beautiful. I said new a bunch of times. I never had to say delete. Java just figures out when I'm done with something and it automatically deletes it for me. It's called garbage collection. That's really nice. Don't have to worry about memory leaks. Memory leaks do not exist in Java. And yeah, the standard library is just amazing, and I will show you how amazing it is compared to C++ right now if we don't have any questions. We're good to keep going? So one thing I'd like to do is show you how to make a program that creates a window on the screen and has buttons that you can click and things that you can see and interact with. That's not something that's part of the C++ standard library. We could not do that. You have to download somebody else's library. It's not part of the standard. So let me teach you one of the built-in graphical user interface libraries in Java. It's called Swing. So we're going to import the package called javax.swing. And we're going to use a bunch of classes that are here. They all start with J, JButton makes a button on the screen. JFrame makes a window. What else? We'll be using JTextArea to display something. So here's what I'd like to do. Let's make a graphical user interface, GUI for short. Let's make a GUI for our counter class. So we'll have a little window that looks like this. And it will display our current counter is count, 0. And then it'll have a button for increment. And then it'll have a button for reset. So we're going to make this. And it'll start like this. And then underlying, it will use our counter object. It'll make a little counter object for itself, which has a count inside of it set to 0. And it will always, that's the database for this window program. And it will, every time we click ink, for example, if I click ink, it will increment the count. I should show it here. It will increment the count in the counter and then change the little text to display the current count. Now it's 1. If I ink it again, or if I press reset now, it'll bring it back to 0. But it's going to modify the underlying counter, and that's what's going to that's the information that's going to be always displayed in the text field. So isn't that nice? That's how we're going to do it. So yeah, we're going to make a GUI finally in this class. Couldn't do it in C++, but we can do it in Java. So yeah, there's a bunch of little components that we're going to bring into. They're just classes that you make. You say new this, new that, new button, new JButton, and that will make something that we can display on a window. And that is part of the Swing library for Java. So yeah, how do I want to do this? Let's see. Do I want to... Yeah, I think I'm just going to copy and paste this one. This is way too much to type, but I'll walk you through it. So let's copy. 28 counter GUI dot Java. Oops. Dot. And so here is the file. I've made a new file called counterGUI.java. Just imported it from before. It's a lot of typing. But it's going to use our counter class that we've already made. This one. It's going to make a counter, and it's going to represent that graphically. All right, so here's how it's doing it. So Java's version of include is import. I'm going to import the javax.swing library. I'm going to import everything. The star stands for everything. So import javax.swing.star. And then when you click a button, it needs to send what's called an event to that button. So I need to deal with those clicks, and so I have to import event stuff too. That's in this library. Not a big deal. So I'm importing these. I guess they're not called libraries. They're called packages. I'm importing everything from those packages. And then here is my public class that's going to do stuff. All right. So just like I said, we're going to keep a real counter object under the hood. That's going to be our database. It's going to store what we want to be displaying on the screen. It's going to keep track of our current count. And we always want to have our window in sync with our database, with our counter object. All right, so here is my counter object that's going to be the ground truth of everything I want to display in the window. We don't have to import counter, by the way, like you might think we do. Because it's in the same folder, Java just knows that it's there, and we can use it. And then static, we're going to say static here so that it belongs to the class, not to an object of the class, because main is also a static method. It's not a method that's part of the class. All right, it's not a method that's part of an object, it's part of the class. And so we're going to give it this. Essentially, a static field is a global variable. So I just made a global variable here. Technically, I could have just made it a local variable in main, but this is more fun. Okay, so once main begins, we're going to build our database, right? C equals new counter. So we're going to make a counter that starts at 0. And now I'm going to put a bunch of J stuff everywhere. So here's the idea. In Java, in the Swing library, it's just a library. You have to learn all the little features of it. But in Java, the window is called a frame. The window is called a frame, and if you want to put a bunch of stuff in the window, you have to arrange them somehow, and usually you arrange them as something called a panel. So I'm going to have a frame, that's the window, and then inside of that we're going to put a panel, and inside of that we're going to put a text field and 2 buttons. Okay, that's going to be our goal. So the frame is our window. JFrame, frame equals new frame. It's just an object, and you make it, and it makes the window. It's really cool. And its constructor takes the title that you want the window to be. So counter GUI. Dun, dun, dun. Here is JFrame. Let's go to its documentation if you want to try this yourself one day. JFrame is the window, and we're going to make a new one of those, and we're going to use this constructor right here to give it a string, and that will have the specified title. Cool. And just while I'm walking you through this, let me just show you it. I have to run it on my virtual machine. Come on. There we go. Oop. So let me get a terminal here. Windows desktop. F22 code from class. 40. What lecture are we? 29. So let me just compile Java C counter GUI.java. And then I'll Java counter GUI it. Here's what we're building. Is this thing. And here's the window title, counter GUI. Counter GUI. And if I click increment, like it starts out at 0 because that's what the current counter's count holds. If I click increment, it's going to call the inc method on my counter and redisplay the new count. If I call it again, if I press the button, it's going to call inc again, update the text field's display. Do this as much as I want. And then reset, we'll call the reset method on our counter and set it back to 0. Okay? So that's what we're building right now. It is a graphical thing. It's beautiful. And then for some reason, frames, J-frames, windows in Java, in Swing, by default, when you click the X button, it doesn't close them for some reason. So we changed that to make it so that when we click the X, it exits the program. That's just what that fancy thing is doing. Okay, what else? So yeah, we want a bunch of stuff in our window, and we have to arrange them in something called a panel. So I'm going to make a J panel. And you can look up the documentation on all this if you want to try your own thing. But that's just going to be something that we can throw a bunch of other J-like things inside. All right, so it'll put everything in order if we put it in a panel. And so the first thing, we want to display the counter's count, and we'll do that in a text field. So this is a J text field right here, this box that has the 0 in it. And its constructor takes how many characters wide you want the text field to be. All right, so this is our TF right here. 3 characters wide, that should be good enough. That's our text field. We're going to keep changing its contents to reflect what the counter's count holds. Okay, we're going to make sure it's not editable. That's something we can change on a text field, because usually you want to be able to type in it, but no, this one is going to be changed programmatically. Whenever we click the button, it's going to be changed automatically. All right, we'll programmatically fill this in, and then the initial text in our text field is whatever the count of our counter is. We're going to keep that in sync. But initially, counter holds 0, and so we're going to get the count and set the text of our text field to that count. And it has to be a string, so we're going to convert from the int that getCount gives us to the string. And this is the toString function, I guess, in Java. It's integer.toString. So it takes an int, gives you back a string. And then I also have this helper function that just makes sure that the font size of the text field is super large. I stole this idea from the internet. Here's that function. It's this fancy thing that I had to come up with and figure out on my own. But that will set the font to be large for this text field. And we'll do that for everybody else too. All right, so that's TF. And then here is the J button for ink. This is both of these two things. Those are J buttons. This is a J text field. And these two guys are J buttons. So eventually we're going to build these up and put them in the panel and then put them in the frame at the very end. So, all right, here is a J button. It's just, you make it in code. You say new J button, and that creates the button. We just have to place it in the window soon. That's all it is to make a window, to make a graphical user interface. It's so cool. So we're going to make this button, make the font size huge, and then we also want to set something up to happen whenever we click it. So here's how you do that. You create what's called an action listener. That's the fancy term in this Swing library, apparently. That's what they called it. So we're going to set up an action listener to listen for the click event, and essentially you can read this code as like, all right, whenever we click the ink button, here are the 2 lines that I want to execute. That's pretty much what's happening. Whenever I click that ink button, what do I need to do? I need to increment the counter's count, because that's what we're using to like keep track of what we want to display. So increment the counter's count if we click the ink button, and then also make sure that the text of the text field is in sync with the new count, because we just changed it. So we're going to call getCount, convert it to a string, set the text to the text field, just like that. All right? So that's what we want to have happen. These 2 lines, we want to have them run every time we click the ink button. So that fancy amount of code is going to make that happen. Okay? Again, I'm not testing you on any of this. This is just because it's cool and I want you to see it. Are there any questions about the ink button and what it does and how it does it? It's just, you have to learn the library, learn how it works, learn all the little words to say, and then it all works out. The reset button is very similar, right? It's another J button. The text in it is reset with a capital R. Make the font size huge, and every time we click the reset button, we want to run these 2 lines. We want to run reset on the actual counter object to set the count back to 0, and then we want to change the text field's text to reflect what the counter's count currently is, which should be 0. All right? So do those 2 lines. So essentially, these 2 all over again, we just swap the ink for reset. And this line is just keeping track of like reflecting the counter's count in the text field. Okay, so I've built up now the text field, the 2 buttons. Now I want to add them into the panel. So They're arranged in this order. I'll add them in that order because of that. So here's the panel. I'll add the text field, ink, then reset in that order. That will put them all there. And then I want to add the panel, right, to the frame. The panel, this whole thing, now put it in the window. Add it to the frame. So we do it like this. Just some fancy words that you have to look up how to do, but then you'll remember it. And then .pack, what that does is it resizes the window to fit exactly to the contents here. Like by default, maybe it would have been something weird looking like this, or maybe it would have been so small that you couldn't see anything. What .pack does is it resizes the window so that it's just big enough to show everything. That's what that does. And then finally, by default, as you're building the window, it's not shown to the user. What we do is we finally, at the very end, once it's ready to be shown, we say, hey, user, here it is. You make it visible finally. It was invisible before that, right? But that is legitimately it. That's how you make a graphical user interface with an object that you understand as like the database behind it. And so I can click increment. It's calling ink on the counter and resetting the text field's display to be whatever the counter's count is. Then you click reset, makes it back to 0, and this is pretty satisfying. Finally, we get to like see the fruits of our labor somewhere other than the terminal, right? So yeah, that is our counter graphical user interface program. Please study this, make up your own. I think if it's fun for me, it's probably going to be fun for you too. So yeah, that is the last piece of Java that I wanted to show you guys. Are there any questions about any of that before we switch to Python? All right, so yeah, let's try to have another language today as well. So that same website, that Learn X and Y Minutes, has another one for Python, so look there too, please. It has a nice little file that teaches you like the ins and outs of Python and the differences with a lot of comments. It's very useful. Please look through it if you're interested. Do the same for the Java one. But let me do my best to teach you the ins and outs of Python in a few slides in the rest of today's lecture. By the way, you might think that like Python is named after the snake. They do have a little mascot that's a cute little snake, but actually the maker of Python named it after the Monty Python comedy group. And so you'll see a lot of references to that in the documentation if you're a fan, which is super fun. So yeah, let me show you the easiest example program in Python. I got to make hello world for you, of course. So let's see. What do I want to do? This is actually going to just be a single line of code. Python is lovely. It's so much easier than C++. Usually, a lot of places, they teach Python first, and you're going to see why right now. Python files, they don't have to have any special naming convention, but people like to end them in .py. That's the extension for a Python program. And so I'm going to make a program called hello.py, and the only line in it is going to be this. I'm going to say print, and I'm going to say in quotes, hello world, ... and then like close it off, close the parenthesis, no semicolon. That is the program. Watch how fun this is. Watch how easy it is. So hello.py, and I'm going to do it like this. Print hello world. By default, the print function in Python adds a new line. So we're good. Ooh, do I want to install a linter? Let's not do that this time. So that's the file. Oh gosh. Fine, install it. We'll see what it does. Are you done? Are you happy? I'm sure it's figuring it out. But while it's doing that, let's run the program. To run the program, here's the file, hello.py. You just say Python 3, that's the version that we care about. Python 3, that's the latest and greatest, and then you say the name of the file.py to run the program. So say Python 3 hello.py. There is no concept of compilation, it's just it runs the program when you give it the file name. And so there it goes, hello world. Isn't that nice? So there is no main function in Python. it's not necessary. It just starts running the code that's there, line by line. You can just start writing code, so that makes it very easy for people who are first starting to learn programming, I would say. It's commonly taught in some schools. And then you just give the file name to Python 3, and then it runs it for you. It's pretty nice. Single line comments in Python programs are like the makefile comments. They start with number signs, so this is a single line comment. If you want multi-line comments, you have to do a fancy kind of string with 3 quotes. You can use 3 single quotes or 3 double quotes, it doesn't matter. This is a multi-line comment. Alright, so that's the program. Hello world. There's no compilation, you just give it to Python 3 and it goes off and runs it. Okay, any questions about any of that before I make it more complicated? Alright, so let me just say some words and then I'll do another version of the counter class for Python this time. Alright, so what are the differences between Python and C++? So first of all, Python is not compiled. It doesn't even have like an intermediate bytecode language like Java does that makes it almost compiled. Python is what's called an interpreted language. There is no compilation process. When you run Python, it looks at each individual character of this. It doesn't convert it to binary or anything. It's like, all right, that's a comment, I'll skip it. All right, this is the start of a comment. Let's keep on reading until I find the end of the comment. Oh, okay, I found print. I find these characters, print. Oh, that's a print function call. Let's run it with whatever the contents are evaluated. So it legitimately just reads the characters of your file and it interprets it. It's like you're speaking a language and it converts it to whatever output you're trying to get at. So there is no concept of converting it to ones and zeros to make it machine code. You just go straight to running the file, which makes it easier to learn about and do stuff quickly, but it makes it a whole lot slower than C++ and Java. It's significantly slower. If you write the same program in Python and C++ and Java, C++ and Java will be light years faster than Python. Right? But that's okay. I mean, there are places where it's okay to do that, to not have to worry too much about like your speed. So let's see, what do I want to do next? Before the counter class, at least. All right, so the next thing is called dynamic typing. Python doesn't really care too much about the types of things like C++ and Java does. You don't have to say like int x, bool y. Python just will figure out the types for you. And because it's not compiled, if you use the wrong types, you're going to get a runtime error. There's no such thing as a compiler error because there is no compilation. So that might be not a good thing. Some people don't like that. So more python.py. So instead of saying like int x equals 42, I can just say x equals 42. Python will figure out that, oh, okay, this is an int we're storing here. Right? There are no types that need to be declared in Python. And it just figures them out. Which is interesting. And like I can print x, and it'll print 42 when I run this program with Python 3, name of the program. Cool. All right. I can also print, Python does know the types of things. It still keeps track of them for its own purposes. Type is a function that gives you back the type of something, so I can print the type of x. That's like, all right, it's an int. It knows. Now let me do something that will make you so uneasy. Watch. X equals a string. Python doesn't care. It's fine with that. X is now a string. It used to be an int. Oh no. That is called dynamic typing. It's whatever it becomes. Doesn't matter. X was 42 and an int. Now it's ASDF and a str. Str is Python's version of the string type. That should make you feel a little weird, given what you know so far. So Python just will figure out the types for you. It doesn't care. It's dynamically typed on the fly. Whatever you give it, it'll figure out the type of it and be happy, usually. Right? Let's see what else. if you want to make a function, because there's no concept of like return types, you have to say like, okay, I'm making a function now. Usually with C++ or Java, you say like the return type first, and that starts off the function. No, with Python, because there are no types involved, you don't speak of them, you say def. That creates a function. Def. Let me start defining a function, please. So def add1, for example. So a function called add1, and it might return something, it might not, depending on how you implement it. You don't declare it up front that, hey, this is going to return something, and here's its type. It doesn't care. Also, you don't put the types of the parameters. You just say, all right, this is going to take a parameter called y. It's going to have some type. Could be anything. And yeah, that's how you start off. There are no braces in Python. So how do you get the body? Python is all about white space. You have to, if you would like to, have a body of a function, a body of an if statement, a body of else. In order to get into the body, you put a colon and then you tab over. So there's no concept of braces. You can't get it wrong. You're kind of forced to write it pretty. I'm sure a lot of you have forgotten a lot of the time to like tab over to make your code look pretty in C++. In Python, you are forced to tab over if you want it to mean what you want it to mean. So this is now the body of the function after I've tabbed over. You put a colon, then you tab over. Everything that's indented is the body of the function. And this will just add 1 to whatever it's given, so return y plus 1 or something. Right? That will be the definition of this function. I can unindent, get back to the rest of the code, like the main function. I can call it now. Print add 1 of 42. So that should print 43 when I run it. Okay? Any questions about that? So instead of braces, you have a colon and then you indent, and everything you indent, it becomes the body. That's kind of nice. Let's see. Yeah, Python is interpreted. Let's go back to that idea. So it's like, it's legitimately reading the file. It's like, all right, here's a comment. Print 2 plus 2, print hi. Python legitimately just reads character by character. It's like, all right, this is a comment. I'll forget about this line. All right, this is print. Let me go and run that, make 4. All right, this is another print. All right, let me go and run that, print hi. It's reading character by character, which probably doesn't make a lot of sense right now. But once you get to like a compiler's class at a 4-year college, it should hopefully like drive it home how inefficient this is interpreting a language. Let's see. Let's talk about lists instead of arrays. Python prefers lists. It's essentially the same thing. You can use indices, everything that you would do with an array, but they can kind of grow to like vectors could. So I can make a list called L, and it holds 1, 2, 3 if you want. And this syntax creates a list, this angle bracket syntax. Or, sorry, yeah, I guess that's an angle bracket, right? So the following is a list. I can make a list of numbers. Again, Python doesn't care about types. Let me scare you a little bit. Here is a valid list. The 0th index, the first 2 things are ints. The third thing is a string. Oh no. Also, strings in Python doesn't care if you use double quotes or single quotes. It's very weird. That's a thing. So instead of this string high, I can make it this string high. And Python's happy with that. There's no concept of like a single character needs to be with single quotes only. Python doesn't really differentiate at that level. And then you can go in, you can access it at every index as you would normally. So this will print high. Okay, that's kind of fun. All right, instead of else if, there's elif. And you also don't put your conditions within braces. That's unnecessary in Python. So I don't know, let's do like a quick grade calculator tool like we did a long time ago. Grade equals 77 or something. And all right, let's convert it to either A, C, or F using an if, else statement. In Python, that will be if, elif, else. So if grade is greater than or equal to 90, again, no need for parentheses, colon, tab over, that makes your body, print A, I don't know, that automatically adds a new line as well. Else if becomes elif, grade greater than or equal to 70, print C. And then else, colon, tab over, print F. Oops. You see the differences there? Pretty much the same, but slightly different. Any questions about any of that? Let's see. When you make a class, and we're going to make the counter class on the next slide, when you make a class in Python, you must explicitly talk about the this parameter. You have to explicitly take it. And in Python, it's called self. So that lab that I gave you was essentially just me preparing you for this lecture. So you know how in C++ I've told you that C.inc is secretly translated into, like, if we made a counter class in C++, this would have been counter : inc called secretly with a 0th parameter call that is the address of the thing that you're calling it with. So everywhere you use this in C++, it's secretly being translated into this. It's essentially a function call. It knows what to do, though. It knows what object you're working with because it secretly gets that thing you're calling with as a parameter. That's how classes work in a programming language, secretly. But in Python, you have to be very explicit about the this parameter. You actually take it. You define it not as like an empty method, a method that takes no arguments. You give it one parameter, and that one is yourself. You take that explicitly when you define it. And then also, I'll show you at the end, Python has some awesome libraries, just like Java does, and I'll show you one of them. So C++ is kind of not as cool when it comes to standard libraries, I would say. So yeah, let's make a counter class in Python now. I'll call it, I guess, counter.py. And here's how we want to use it. C equals, there's no concept of new in Python. You just call the constructor. C.inc. Do that a few times. There's no semicolons in Python because it's all about white space. Only one thing can go on one line. Only one statement can go on one line. Print c.getCount. I can make another counter. Again, no need for a type, no need for new. Maybe we'll give a parameterized constructor. You can have default values in Python. c2.inc. c2.inc again. Print c2.getCount. So if we implement all this correctly, this should give us 3 and 44. So here's how you implement the counter class. You say class counter, and then no braces, it's colon. Colon tab over, give whatever you want here. All right. So we're going to need a member variable, first of all, and we're also going to need a constructor. Let me show you how weird this is going to get. So first of all, different to C++ and Java, the constructor in Python for a class, it's not a method with the same name as the class. It's a method called __init __. That is the name of your constructor. That's what it must be called. And every method, like I was saying, takes explicitly an explicit self parameter first. But that secret self parameter that is now made explicit in the definition, there is no declaration in Python, just like in Java, it becomes implicit in the use, which is a little weird, but it's automatically passed when you call a method. Because it's like, all right, c.inc, it's essentially call inc with the address of C kind of thing. It's going to do it for you when you use it, but when you define it, Python forces you to be explicit about it. So let's make the constructor def underscore underscore init underscore underscore. It's going to take a self as its secret first parameter, and optionally, we'll take another parameter. We're going to take either nothing or the first value that we want our count to be. So count, let's start it by default at 0 if we don't give anything. Fields in Python are created inside of the constructor. You don't put them outside, you don't declare them outside, you make them inside of the constructor itself, which is very similar to JavaScript if you've written JavaScript before. So we're going to make a field called count, and it needs to live inside of, it needs to begin its life inside of this constructor. Let's make a field called count. Fields get made in the constructor. So we can't just say count equals count. That would be, first of all, ambiguous. Second of all, it would be a local variable. I would like a member variable. It's got to go through self. Self.count equals count. That's where the member variable gets its life. So that is the one line we want in our constructor. Set the counter's count, just like this. All right. Now let's do inc and reset. Sorry, get count. That's what we're doing next. So we're only using inc and get count. Just a bunch of incs and get counts. All right. Next method, def inc. Explicitly, we have to take self. What do we want to do to ourselves when we inc? Well, we better increment our count. Self.count. There's no plus plus in Python, sadly. You have to say plus equals 1. That's the shortest you can make it. And then get count. Explicitly takes yourself, and it returns your count. You can only access your member variables through self. And we explicitly say stuff about self in the definition of our methods. But when we use them, we don't have to do that. It's going to get done for us. So this gets translated to like inc of C or something. It's going to pass the object itself as the self for you, as the method call. All right. So that's why you can call it like this, and this is why you don't have to give anything here, because it's like implicitly it's going to be the object will be yourself. But you have to explicitly talk about it in Python. All right. So I believe that's everything. If we run this, we get 3 and 44, just like the comments tell us that we should. Awesome. And so this is the implementation of the counter class. Does that make sense? Any questions about that? So yeah, just one last thing about this idea to drive it home one last time. When you call inc in C++, like c.inc, it's going to really translate it like this to you. And inside of the implementation of that function, you always have a pointer called this. It sets it for you. It's always a pointer to your current object. Whatever that is. It could be a counter object, could be whatever your method is right now. Got called, and this is being set to be a pointer to that current object that you call that method on. And that is what Python is doing with self. Self is, if you say self, it is your current object. It's not like a pointer or a reference. It's just, it is the object in some sense. You can think of it maybe as a reference since you're using dom, but it's a little bit different. Okay, that's the idea. Any questions about any of that? So that's classes in Python. And all of this indentation is very important. You cannot mess up. You cannot put multiple things on a line. It all has to be pretty like this. Python forces it to be pretty. All right. One fun library that I want to show you before we end is called the Turtle library. It's very cute. It's another graphical library, kind of like Swing. But what it does is it lets you draw stuff. So for example, you can use the Turtle library, and this is the program that you can use to draw this pretty picture, among other things. So here is the cute little metaphor, and the documentation is awesome. can look through all this if you're interested. This is the turtle library. There are a bunch of other libraries in Python if you go to like the table of contents. So many nice things that they give you. Here's one of them. It's the turtle library. So it's for programmatically drawing stuff. I like to use this in my CSCI 1 class. I teach Python and the turtle library there to those students. So this is a sneak peek of that. So here's a turtle. Here's the metaphor. Cute little turtle. And that is the head of the turtle, first of all. Turtles have tails. And the metaphor is, for this turtle library, is we have this turtle that can understand English, can understand our commands, and then also the turtle accidentally dipped its tail in ink somehow. All right? And here's what you can do with this sentient turtle that you can command. You can ask the turtle to like move his tail up or down. Default starts down. And then you can ask him to move around on a two-dimensional grid. You can say, hey turtle, move forward, and then it'll make a line because his tail was dipped in ink. Hey turtle, move, turn to the left. Okay, now move forward. And you'll start drawing stuff. Does that make sense? That is the turtle library. And so let's draw some stuff with the turtle library before we go. So, turtle example.py. Import. You also say import just like Java for Python stuff, but there's no semicolon. So import turtle to get the turtle library. And now everything that we've taken from the turtle library, you have to prefix it with turtle dot. So like if I want to set the shape of the turtle, as I will, because the default is this silly looking arrow thing. No, the turtle should be shaped like a turtle. So you can say turtle dot shape, and then give as a string turtle. So turtle dot shape turtle. And I will also make the turtle move quickly. So we don't have a lot of time. Say turtle.speed fastest. Or you can make a turtle move very slowly so you can watch things work. Maybe we should do that first. Turtle.speed slowest. But everything from this library needs to be prefixed with the name of the library. That's Python's version of like namespace. So when you start your turtle program, the turtle begins its life in the middle of the screen. And there's coordinates. The turtle starts out at 0, 0, facing east. So if I draw a picture of that, here is your coordinate system. The turtle starts out in the middle of the screen at 0, 0, facing to the right, facing east, we say. All right? So let's, and you can tell the turtle, hey, here's what color I want you to dip your tail in, like turtle.pen color sets the color to something like pink, I don't know. So you can change the color that the turtle's going to draw stuff with. It gets very fancy. And so let's tell the turtle to move forward by 100 units in its current direction, which is east. Right? So let's see what happens if we do that. And of course I get red lines, but let's not worry about that. So come back here, Python 3 turtle example.py. And darn, the turtle drew something and then he immediately ended the program. So one thing that you have to do if you want it to stay open is you say turtle.done. Please wait after you've drawn stuff, Mr. Turtle. So you have a turtle shaped like a turtle, and it moved to the right, and it drew a line of length 100 units, whatever that is. Okay, so the turtle can respond to us and draw cool stuff. So let's draw a square with the turtle library. Let's see how cool this can be. So the turtle just drew this. We next, all right, turtle started here, facing that way. We went forward 100 units. Now we want to draw this part of the square. We can't go forward right now because the turtle's facing this way. It'll draw over here. But you can tell the turtle, hey, this is your current direction. Please move to the left 90 degrees. Turn to the left 90 degrees, please. Let's turn 90 degrees to the left. And that will get us in the right spot. Turtle.left 90. And so now he's turned to the left 90, ready to go forward again. Forward 100. And I think you can imagine what needs to happen next. It's just a bunch of those. So, again, turn to the left. We want to go over here. By default, what is all that? By default, we were facing this way. We need to turn to the left another 90 degrees, go forward 100. And then we're facing this way. But now we want to go down, so turn to the left another 90 degrees so that we finally face in the correct direction to go forward one last time, right? So that's essentially what needs to happen here. Just the code is here. Let's go left and forward a few more times. Boop, boop. And so that's 4 100s. That should draw the square. Where I've lost my mouse. Great. This will get interesting. Let's see if I can bring the mouse back somehow. Control-Alt-Delete. That is hilarious. All right, I don't know how I lost my mouse, guys, but let me figure out how to get it back. Does anybody know? Does it? Weird. All right, Control-Delete. That's a mouse. Cool. That'll fix things. All right, try again. And so just a bunch of left turns and forwards. We make a square. Does that make enough sense? So let's do something slightly more complicated. Let's make a triangle. That's going to get a little more complicated. Let's get the turtle in a spot to draw the triangle. Let's like draw a triangle down here a little bit. Down here a little bit. And then we'll draw a triangle like this. Boop. Draw like an equilateral triangle or something. All the same side lengths, all the same angles, right? But one thing I can't do is I can't just say, hey, turtle, go forward a little bit more, because that's your current direction, because watch what will happen. How much forward do I want to go is the first question. Let's say forward by 200 to get to a spot to draw the triangle. That's no fun because he's still making marks. So you can ask the turtle to pick up his tail and not make marks when he moves by saying turtle dot up. Like, pick up your tail, please. And then we'll get you in the right position, and then we'll put your tail back down so you can start drawing more stuff. So let's set the color for the turtle now to be like blue. So it'll draw a blue triangle. Okay? So turtle dot forward 200, and now turtle dot down to start drawing again. Put your tail down. And now the question is, how can we draw this triangle? Let's draw it like this. Let's first go this way, which is going to require us to face in this direction. Right now, we're facing in this direction, so we need to turn again. Turn left 90 to get to the right spot. And then we'll go forward by, I don't know, is it 100 again? That will work. And then we need to, like, turn. Turn some more. Does anybody remember the angles for an equilateral triangle? What are the angles inside? They're all 60, yeah. If it's all the same, it better be the same angle. So 60, 60, 60. So I need to turn left and go forward. Oh, shoot. I got too much going on right now. So I need to turn left 90 so that I'm ready, because by default we were moving down this way. Turn left 90 so we can go this way. And then we can go forward 100 to draw the bottom part of this triangle. All right, turtle dot forward 100. And so that'll be a good start. Get in the right position, pick up your tail up, make it blue, and now we need to draw the rest of the triangle. So, I don't know, turtle left. We do need to turn to the left, right? Left 60, forward 100. There's an issue with that. Does anybody see the issue right now? Well, it's not what the turtle's telling me right now. These are all correct things to say. Turtle left 60, turtle forward 100. I bet you never thought you'd ever have to use geometry again. But that was not the correct angle. Let's figure out why. And I've lost my mouse once more. Well, we can do some things without the mouse. Oh, that worked. So I turned left by 60. That was not enough. Because the turtle was facing this way. If I moved him forward, it would have gone more in that direction. I want him to move this way so that he goes forward in that direction. Does that make sense? So what is this angle he needs to turn left by? Because it's not 60. It is, well, if this is a line, it is just the rest of the line, right? To make 180 total. So this must be 120. I better be moving left by 120. Not 60, because that's the full angle. It's this large angle, not a short one. It's not an acute angle. It's, what was it, oblique? I forget the word. Okay, so we're not turning left by 60, it's 180 minus 60. You can do it like that. Then go forward 100. And that should be happy. Yay, and that's actually the angle we want for everybody, so that will correctly make it work. So one last thing. It's again like the turtle is facing this way. We need to turn this way, which is 60 plus blank equals 180. That's the 120 again. And then we can go forward one last time. All right? So that will give us a complete program. And I keep going here. That once more. And that should be a correct triangle this time. So a bunch of forwards and lefts. Yay! So it's beautiful. This is a very simple example, of course. You can make this so much more complicated. And cool, I still have a mouse. You can do very fancy things. Let's see, what do I want to show you? I guess there is this example up here, which is cool. There's also, do we have time for it? Did I do this last time even? I don't know. Here's a cool example I showed my CSCI 41 students today. Copy. Excuse you. Is it not working? Copy. What's here? Oh, sorry, 2 dots. You know that one, what's it called? Does everybody know that one Joy Division album that everybody likes to wear on their t-shirts? You can make that in Python. Because what is, I don't know, with the turtle library? Because the cover art on that particular album is just data that was read back in the 60s from some celestial body called a pulsar that I don't fully understand. It emits radiation, and we can just take those readings and make a program that draws stuff with those readings. So I guess this was discovered in 1967. There was the readout, and then that radio signal was turned into a visualization on this album. And we can just take that data and recreate this album cover in Python. Isn't that cool? So here's the data. It's just a list of lists, one for each line of the output that we want to read. Every oscillation of the pulsar. I don't even know if I'm pronouncing that correctly. But that's okay. We can write code for it. And so there's a lot going on here. You can make some functions that do stuff, but it really is just the turtle library. Plus a little randomness maybe. Draw a rectangle, draw a polygon, draw a line, draw a fuzzy line. Just a bunch of loops and variables and turtle stuff. So it goes to show that you can do anything. And so here is the turtle library drawing the Joy Division album cover. This is one fun example. And it's going to take a while because it's a complicated program. And the turtle library is probably not the best thing for it, but that's okay. It'll get there in the end. But yeah, you can make some really cool graphics just with the turtle library. So do not think that it's just for kids or something. It is very fun, and I encourage you to play around with it. So let me look at my notes while it's trying to draw. Okay, I have one last thing to show you. It's getting there. But yeah, it's just taking these numbers and converting them to pictures and overwriting stuff that it had already drawn before. But yeah, it's just a little virtual canvas that you get with the turtle library. You can set the background to, like I did, to black instead of white. And not only do you get the cool album art, but you also get a turtle at the end. How fun. Alright, so the last thing that I wanted to show you that you've probably seen me use in class is Python's REPL. If you just say Python 3 without the name of a program, it will plop you into something called a REPL, Python 3, which stands for Read, Evaluate, Print, Loop. So you just type some quick lines of Python and it will run those for you, like 2 plus 2. It will, once I press enter, it gave me a prompt, it will read the 2 plus 2, evaluate it to 4, print it out, and then give me a new REPL prompt to do the next thing all over again. It's a loop. Read, evaluate, print. Read, evaluate, print. X equals 42. X plus 7. It will do that for you. And so you can do some quick math with it. That's what I've been doing in class, I think. Like, hey, is this number mod, this number what I expect it to be? Rather than having to write a fancy C++ program to do the same thing, consider using Python. Also, Python numbers, like they're to the power of operators 2 stars. You can do arbitrary precision math in Python. It doesn't overflow, so it figures out the right answer. So yeah, I think that's everything that I wanted to show you about Python. Are there any questions about anything that we talked about today? I guess Java too. So yeah, fun stuff. Study up on it, because you might be transferring to a school where they learned Python first, where they learned Java first. But now you've seen it, so you can learn it. All right, so the very last thing that I want to show you today is your very last lab, Lab 11. This will be due last week of classes, so the second, next week, next Friday. That's it. Your final lab. Let's take a look. This one's about the bitwise operations. All right, so Lab 11, let's take a look at it. Start code. Very slow today. So here are your files, and you'll probably be working most in bitops.cpp, but let's take a look at all of them. So yeah, take a look at bitops.h and bitops.cpp. You're going to implement every function that's declared in the header files. Back to C++ mode, bitops.h. So here are the 3 functions that you will be implementing: isBitSet, countBits, and setBit. So you're going to be given a number as an unsigned int, so there's no weird negation stuff, and then an int called I. So what you're supposed to do is go in n and return true if bit I of n is set to a 1. Set means it's a 1. If it's not set, if it's a 0, then you return false. Okay, so that's the idea. That's what you're going to be doing for that one. Count bits is just go through every single bit in the integer. There are 32 bits in every integer, bits 0 through 31. Look at all of them. count how many of them are set. How many ones are in the binary encoding of that number. Okay, so that's your next option. And then finally, make a function that sets a bit, takes a number by reference, and sets bit I to a 1 if it wasn't already a 1 already. Okay. So those are your 3 functions. Remember that every int has 32 bits, and bit 0 is the rightmost bit. So for example, this 0, 1, 1 here, the 0th bit is a 1, the bit number 1 is a 1, bit number 2 is a 1, bit number 3 is a 0. All right? So it goes from the right. The rightmost bit is bit 0. The next bit is bit 1. It goes up to 31, bit number 31. Okay? So yeah, I think I've explained all of these. Is bit set checks whether bit I of a number n is set. Remember which bitwise operator can get you that. Count bits looks at every single bit, bits 0 through 31, and figures out how many are set. So for example, if you're given the number 7, which is a bunch of zeros, and then 3 ones at the very end, so 4 plus 2 plus 1, that's 7, right? There are only 3 bits that are set to a 1. Everybody else is a 0. So count bits on the number 7 should return 3, because there are 3 ones in the binary encoding. Okay? And then set bit takes a number by reference and puts a 1 at that location. Sets bit I to a 1. Okay? So those are the 3 things that you'll be implementing in bitops.cbp. Is bit set, count bit, set bit. Hint, it's very easy to implement count bits after you've implemented is bit set. You can just use it a bunch of times. So do that, please. And then this is where you'll implement all that. And then finally, write a bunch of tests. So I've given you a bunch of tests already. You'll add to those, of course. So here are a few of them. Here's all my tests, like assert that the 0th bit of 15 is set, and the 1st, and the 2nd, and the 3rd. Bit 0, 1, 2, and 3 of 15, because 15 is 1, 1, 1, 1 in binary. All those first 4 bits are set. But every bit after that is not set. So is bit set better be false at the end of that one. Okay? So that's how it all works. There's only, the number 2 is 1, 0, so only 1 bit is set. So if you count all the bits in 2, that's 1. Count all the bits in 7, it's 3. Count all the bits in -1. Even though it takes an unsigned int, it will correctly translate it. And every bit, remember that -1 is every bit being set. So that's 32. And this is just checking that you've set all the bits properly. Right? Test set bit, etc., etc. Right? So get those passing. And then I guess all I want are 2 more tests. Make them fancy, make them simple, whatever you want to do. But write 2 more tests, please, to check potentially some combination of your bitwise functions that you wrote in bitops.cbp. Okay. So yeah, get my test to pass, make 2 more, and that is it. That is your final lab in the class. So you're turning in the 2 files that you touched, bitops.cbp, and the test file. Okay? And that is it. That's the last lab introduction. Are there any questions about it? So yeah, just go back through all the bitwise stuff that we were talking about and get all that implemented. So that'll be due next week, next Friday, the last day of classes. All right, I believe that is everything that I want.